blank page, you are going to write example number 4 and example number 5. Oh, you already wrote the poker ones on that one? Then go to page 751. Either one of those two pages are blank. So example 4, find the term containing x to the 9 in the expansion of 3x squared minus 2 over x to the power of 9. So these last questions that we're going to do are examples of the more difficult questions that involve the binomial theorem. First of all, how many terms would there be if we expanded it completely? 10. So one method of solving this is to expand it completely, find all 10 terms, simplify it, and then find the one that has x to the 9. That's the long way of going about this, but if you forget the shorter way of going about this, that might be your choice. The shorter way is we can use our formula. So we have this formula, tk plus 1 equals n choose k, a to the n minus k, b to the k. And we can think about this formula and say we know some things, but we don't know everything. We don't know which term it is, so we don't know the value of k. But if I fill in everything that I do know, as a start, I know that n is 9. I don't know k. I know that a is 3x squared. And I know that n is 9, but I don't know k. And I know that b is negative 2 over x, but I don't know k. I also know that my term k plus 1 is going to be something x to the 9. Agreed? We don't know what that number is in front, that's why I have that line there. But it's going to be something x to the 9. So if I know that, and I know that this side is 9 choose k, I'm going to just rewrite everything else that I know. The only thing we're going to use to figure this out is we know we need an x to the 9. We are going to ignore everything that happens to be the coefficient or the number in front and just think about our variable and the exponents. Does it make sense? On this side I have x to the 9. On this side I'm going to have in my first bracket, if I ignore the 3, because that number affects the value in front, I'm going to have 18 minus 2k in that bracket. And if I ignore, well, I'm going to just write the negative 2 here right now and apply my exponent law. Does it make sense that I'd have an x to the k on the bottom? What exponent law do you do when you divide? X to the 18 minus 2k divided by x to the k. What exponent law do you do if the bases are the same and you're dividing? You subtract. So now I'm going to ignore that negative 2 because that would, this value, sorry, should be in brackets. That value will be, again, a number in front. If I subtract, I'm going to get 18 minus 2k minus k. And so x to the 9 has to equal x to the 18 minus 3k. Does this look similar to when we were in our exponents and logs unit? If you were able to get both sides the same base, then the exponents have to be equal. So 9 has to equal 18 minus 3k. So 3k is equal to 9, and k is equal to 3. So that tells us it's going to be term 4. Now, the question didn't say find which term has an x to the 9. It said find the term. So we spent all that work just to find out that it's term 4. And now that we know it's term 4, we have to go back and now what exactly is term 4? We can find the number that would be in front of it. So if we want to find term 4 is going to equal 9, choose 3. Our first value was 3x squared to the 9 minus 3. And our second value is negative 2 over x to the 3. Again, we solve each of these things separately to begin with. Go to our calculator. 9 choose 3 is 84. 3 to the power of 6 is 729. X squared to the power of 6 will be x to the 12. Negative 2 to the power of 3 will be negative 8. And x to the power of 3. We can now multiply our numbers together. So 84 times 729 times a negative 8. Negative 489. 888. And what's going to happen with an x to the 12 on the top and an x cubed on the bottom? It's going to simplify to become x to the 9, which is what we wanted. So now we have found the term that contains an x to the 9.
Can I just clarify the first part where you have x to the 9 is equal to x to the power of 18 minus 2k times negative 2k divided by x?
Right here.
That one exactly. So what did you do? Just did x to the negative k there, right?
X to the when I subtracted the k. Okay?
What has to do with the negative 2?
This negative 2 right here, I ignored it. Just like I ignored whatever involved the number in front. 9 choose k is a number in front. I'm going to temporarily ignore it. This 3, I temporarily ignored. That negative 2, in the end, I ignored as well. Okay? The reason we ignore those things is all of those things that I circled in red, they affect the number in front. But that doesn't help us solve what k is. We only use the powers with the variable x to help us figure out what k is. Now, what I showed you here is an algebraic way of doing it. Depending on your exam, some exams require the algebraic way. They say solve for this algebraically, and you need to show your work with exponents all the way through. You have to put like a little note here. I'm going to just ignore the coefficients temporarily. So we ignore our coefficients temporarily, and we just use our powers to figure out what k is. If it doesn't say algebraically, it does not take very long to guess and check to figure out a k value that works. So for example, now I'm going to show you method 2, which is quicker. If I wanted to find the value of k. So pick a value of k. Pick one that's not right. We already know that k is 3. So you pick k as 2. If you pick k as 2, you say to yourself, if k is 2, can I see that this 9 minus 2 is going to be 7? And I will have x to the 14 on top because it'll be x squared to the 7. And if k is 2, I would have an x squared on the bottom. That will give me an x to the 12. That's too much. I want an x to the 9. So should I make k bigger or smaller?
Bigger.
Bigger, because you want more x's on the bottom and you want less x's on the top. And then you would try 3 and you would find it right away. And it would be very quick. So if you don't have to use an algebraic method, I think a lot of these questions, and you'll find some on your pretest as well, that you can just look at them and say, I know that k has to be 4. That's the only value that makes sense. Or k is 3. In this case, k is 3. Okay, so now we're going to do example 5. Example 5. Find the constant term in the expansion of 5x cubed minus 2 over x to the power 12. Now, I forgot the t on the end of word constant. Find the constant term in the expansion of 5x cubed minus 2 over x to the 12. The reason this is the hardest one is you will forget what the word constant term is. Okay? It's not the last term. Could be in the middle, but it is the one that has no variables. A constant is just like 5 or just like 382. In other words, it's the one that has an x to the 0. I'm going to ask you a constant term one probably on your quiz tomorrow. And someone's going to put up their hand and say, what does constant term mean? And I'm going to say exactly, I'm going to tell you what I'm going to tell you tomorrow. I'm going to say, if you don't know, expand it completely. In this case, find all 13 terms, and maybe one of them jumps out at you. That's the long way to do it, but that's what I'm going to tell you tomorrow. Okay? So if you forget what constant term is, that's the one that has no x's. That's just a number. So we do this the same as we did example 4. We say to ourselves, well, according to my formula, I don't know which term it is, so I don't know k. I know that n is 12, so it'll be 12, choose k. I know that my first term is 5x cubed to the 12 minus k. I know that my second term is negative 2 over x to the k. And because it's a constant term, it's going to be something with an x to the 0. So this time we're going to start with the guess and check. Pick a value of k. Hopefully you pick a wrong value of k. K is 5. So let's try it. So if we try k is 5, if I put in 5 for k here, can you see that this exponent's going to be 7? X cubed to the 7 will give me x to the 21 on top. And if I put 5 in for k in the second one, can you see that you're going to get x to the 5 on the bottom? When that simplifies, you get x to the 16. What do we want? We want x to the 0. So should we, for our next logical, educated guess, should we pick a value for k that's larger than 5 or smaller than 5? Larger than 5. So what would you like to try next? 11. So if we try 11, here I'm going to have on the top x cubed to the 1, which is x cubed, and 11 here would give me x to the 11 on the bottom. That ends up with x to the negative 8. So we need to try another value of k. Should I go bigger than 11 or less than 11? Less than 11. 8. Okay? If I try 8, this is going to be 12 minus 8, which is 4, will give me x to the 12 on top. Oh, we're getting closer. We're down to x to the 4. So the guess and check method, or the educated guess, could be long if you happen to guess all the wrong ones first until you get to the right one. But by now, I think someone knows what k should be. If k is 9, on the top you would have x cubed to the 3, which is x to the 9. And on the bottom you would have x to the 9, which would simplify to x to the 0, or all your x's would cancel out. So what we're looking for is term 10. If k is 9, we want to find term 10. So let's find term 10. Term 10 is equal to 12 choose 10, 5x cubed to the 12 minus 10, and negative 2 over x to the 10. Again, we calculate each of these things separately first. Choose 10 on our calculator is 66. 12 minus 10 is 2. 5 squared is 25. X to the 6. 2 to the 10. 1024. It will be positive. Oh, what did I do wrong? Nope. Nobody pointed it out. What did I do wrong? What should be 9?
Be 12 minus 9.
Oh my goodness, guys. If it's term 10, what's k? 9. So all of these needed to be 9s. So that will change all of our values in here. Okay.
Except for 1.
12 choose 9. 12 choose 9. 220. 5 cubed is 125. X cubed to the 3 is x to the 9. Negative 2 to the 9 is negative 512 over x to the 9. Notice that your x to the 9s cancel out, which gives us our constant term. We multiply all of our numbers together, 220 times 125 times negative 512. We get a very nice big number for our constant term. This is a 0. 1408. 14,080,000.
Is that a good amount to be in debt?
So that's a large number. So homework, you can do number 9. If I would summarize the difficult ones, you've already, they have words like, you did one already that said last term. So you need to know how many terms there are in order to find the last term. There will be some questions that say, find the middle term. So for example, in this one, if I asked you to find the middle term in example 5, you would have to know that there's 13 terms. Which is the one in the middle? The term 7 would be the one in the middle. What do people do when they do it wrong? They do term 6. Term 6 is not in the middle. There's 13 of them. So you have to imagine there's 6 on this side, 6 on this side. The 7th one is the one right in the middle.
What happens if you give up, would you ever ask that for an odd amount of terms, or would you find?
Then there is no middle term. No. So last term, middle term, this one that we just did, constant term, you have to know that you're finding x to the 0. And constant term is a kind of question like example 4. And in example 4, we had the terminology, find the term containing a certain one. So the green ones are kind of the same kind of question. The blue ones are kind of the same kind of question. The blue ones require that you know how many terms there are. So that's the little extra step. The last term you have to know, oh, if the exponent's 9, there's 10 terms. The green ones require either that algebraic method or the guess and check method to find out what k is. And this is the end of chapter 8.